let's continue with the second part of proving that implicit and explicit differentiation can result in the same solution if we when finding the derivatives. I just want to point out a small mistake that I made in the last video. Here, instead of writing x squared, I wrote 2x squared, and if we replace that, we will get that dy over dx is minus 5x plus 2 times x to the third power over the square root of 4 minus 5x squared plus x to the fourth power. And if you notice, that's the same thing that we got through explicit differentiation. Today I'm going to show you that if you replace dy with the negative square root that we found through when finding the explicit form of the function, you will get the same result as here, or that dy over dx is equal to 10 times x minus 4 x cubed over 2 times the square root of 4 minus 5x squared plus x to the fourth power. On this paper I have calculated that, and we can notice that we get the same thing basically. So if we replace x in this, if we replace y in this equation with the negative square root of 4 minus 5x squared plus x to the fourth power, through solving we will get that dy over dx is is equal to minus of minus 5x plus 2 times x to the third power over the square root of 4 minus 5x squared plus x to the fourth power. If we calculate the minus as well, we'll get a plus here and a minus here, and that is the same thing that we got through explicit differentiation. Okay, now finally let's look at the graph of this equation. Now, why do we have two solutions? We found the derivative through the explicit form, and why do we have one equation? We found the derivative through implicit form. Well, if you notice, it's basically the same thing. How? You may wonder. Well, if we have, let's say, a point here, and we wish to find the derivative on this point here in the first quadrant, we will notice that the derivative at this point is a negative. And through the implicit differentiation, we notice that if we replace x and y with positive coordinates, we'll get this, we'll find the derivative at this point on the graph. But through the explicit form, if we replace x in this case, since x is the only variable when finding the derivative, we will get two solutions: the solution on the left and on the right, through the differentiation of the positive and negative square root of y. And since the y here is positive, if we replace, and we know that the derivative at this point is equal to a negative, if we replace x in these two equations, the negative solution of the derivative will be the correct one for y at this point and for x at this point. So basically, these two equations, when finding the derivative through explicit differentiation, you only get to input one variable that will get us the derivative of this point here and on this point here. Or since this is a negative slope, this is the negative derivative, this is the positive derivative at two different y coordinates. And that's it.